In the view of the forthcoming JAMB 2025, I want to walk you through the most likely question you are going to expect on reflection. With no further ado, let's get right into the video. A man 1.5 meters tall is standing 3 meters in front of a pinhole camera whose distance between the hole and the screen is 0.1 meters. What is the height of the image of the man on the screen? We are given option A to be 0.15 meters, option B to be 0.30 meters, option C to be 1.00 meters, option D to be 0.05 meters. So let's get into the solving. If you are given a pinhole camera, you must remember the sketch of a pinhole camera, okay, to be able to analyze this question critically. Now this is a pinhole camera and this is the object, which is the man standing in front of it. Okay, now this is the man, right? Now the distance between this man and the pinhole camera, now this man is 1.5 meters tall. So the height of the man is 1.5 meters. That is the height of the man, right? Okay, then from the question, the man is standing 3 meters away behind the pinhole. Now from here to here, distance between this man and the pinhole is what? 3 meters. Remember, this pinhole camera always form an inverted image, okay, because of the intersection that occurs at this middle point or the pinpoint. Now let's go. There is an intersection that occurs here, right? Now the image of this man will be found here when it is what? Inverted. Is that clear? Alright, from the question, the distance between the hole and the screen is 0.1 meters. Look at the hole, okay, and look at the screen. So the distance is what? 0.1 meters, right? So what are we looking for? We are looking for what? The height of the image of the man on the screen. So this is the height. We are looking for height of the image. Now for us to solve this, we are going to use magnification formula to solve. And magnification is equals to M is equals to height of image over height of what? Object, right? Then is equals to length of camera over distance of object from pinhole, right? Now what's the height of the image? That's what you are looking for. Hi all over the height of the object is given as 1.5. I have 1.5 is equals to the length of camera. This is the distance of image from the pinhole and also known as the length of camera. So it's given as 0.1 divided by the distance of object from pinhole is given as 3, right? So simply we're going to do cross multiply. Now 3 height of image is equals to 0.1 multiplied by 1.5, right? So I divide both sides with coefficient of height of image, okay? Then what do I have? If I divide this self and divide this, I'm going to have 0.5. By the time I multiply by 0.1, the answer becomes 0.05 meters. Is that clear? Now from what you have gotten so far, the correct option to this question is option D. I hope that is clear. A ray of light makes an angle of 35 degrees with a plane mirror. What is the angle of reflection? We have option A to be 55 degrees, option B to be 35 degrees, option C to be 70 degrees, and option D to be 65 degrees. If you hear a plane mirror, what will come to your mind is this. This is a plane mirror, right? Now a plane mirror must have what? Normal, right? But from the question, this remains an angle of 35 degrees with the plane mirror. So that means the angle is this way. This angle is called the glancing angle, right? We're asked to find the angle of reflection. So how do you get the angle of reflection? Looking at what we have, this one is already a perpendicular line, which is what to say to be our what? Normal, right? Why this is the incident ray. Now this is the angle of incidence. That is the angle between the normal and the incident ray. Now for us to get the angle of incidence I, right, we are going to say that this is a rectangle. So we have that saying that 35 plus I is equal to what? 90 degrees, right? Rectangle is an angle of 90 degrees. So we are going to say I is equals to 90 minus what? 35. Okay? By the time we subtract, we're going to give us 55 degrees. You must remember from the law of reflection that the angle of incidence I equals the angle of reflection R. So with that being said, we can now say that I is equals to what? R, and that is equals to 55 degrees, right? Now from what you have gotten so far, the correct option to this question is option A. If two plane mirrors are positioned side by side, the number of images formed is 8. At what angle are they positioned? Option A 30 degrees, option B 40 degrees, option C 60 degrees, and option D 90 degrees. The relationship that connects the number of images and the angle is given as n equals 360 over theta minus 1, right? Now let's work out what we have. We are told that the number of images is 8 and looking for the angle where they are positioned. Alright, so we are going to say 8 is equals to 360 over theta minus 1, right? Let me take this one to the other side. I'm going to have 8 plus 1 is equals to 360 over theta, right? Now that is going to give me 9 is equals to 360 over theta. Okay, so I'm going to say cross multiply 9 theta is equals to 360, right? So I'll divide both sides by what? By 9, right? So by the time we divide, the answer is going to be what? 9 into itself 1, 9 into 30 is going to have what? 4. So the answer is going to be 40 degrees. I hope that is clear. And from what you have gotten so far, the correct option is option B. Two mirrors M1, M2 are inclined at right angles as shown below. Calculate the angle of reflection of the ray of light at mirror 2, that is M2. Alright, so you're given option A to be 30 degrees, option B to be 45 degrees, option C to be 60 degrees, and option D 90 degrees. Now look at the diagram on the board. We are going to use the illustration of this diagram to solve our problem. For us to solve this, we are going to use the short method to solve this because you're supposed to solve a particular question in physics in less than 30 seconds, right? So we need to go straight to the point to tell you how to solve this particular question. Now, this is the first mirror. Okay, remember that a mirror must have angle of incidence and angle of what? Reflection, right? And both are equal to each other. So if the angle of incidence is 30 degrees, here is equally what? 30 degrees. Okay? Alright, now this is normal. Normal is a line that is perpendicular to the reflecting surface, right? And it is a 90 degrees because it's perpendicular. Now, this is for the first mirror. This is my angle of incidence. This is my angle of what? Reflection. And they are equal to each other. If this is normal, normal is 90 degrees and the angle of reflection here is 30 degrees. What will be the glancing angle here? We are going to say that 90 minus 30 is going to give me 60. So here is 60. Okay? Now if you have gotten this, you need to get this angle here because this one already formed what? A triangle. And sum of angles in a triangle is equal to 180 degrees. Now if this is 90 90 plus 60 is what? Is 150. Now we are left with how many? We are left with 30 to complete is 180, right? So angle here will be what? Will be 30 degrees, right? And we have gotten to mirror 2. At mirror 2, we are going to have our normal. Now using our normal, which is 90 degrees, if we have our glancing angle to be 30 degrees, what will be my angle of incidence? We are going to say 90 minus 30 here to give me what? 60. Is that clear? Now from the law of reflection, the angle of incidence I equals the angle of reflection R. So with that being said, we can now say that our reflection is equals to what? To 60 degrees. So the angle of reflection at mirror 2 is what? 60 degrees. So my R, which is second angle of reflection at mirror 2 is equals to 60 degrees. I hope that is clear. So if you have this type of question, this is how you are going to solve it, right? And the correct option to this question is option C. A man stands 4 meters in front of a plane mirror. If the mirror is moved 1 meter towards the man, the distance between him and his image is what? Option A 3 meters, option B 5 meters, option C 6 meters, and option D 10 meters. So let's solve this question. What we must know in this question is this man stands 4 meters in front of a plane mirror, right? So this is a plane mirror here. Okay, all right, so look at the man. Okay, now he's standing how many meters? 4. The distance between him and the mirror is 4 meters, right? Okay, if the mirror is moved 1 meter towards the man, that means they shifted this mirror this way. Now they shifted the mirror this way, the mirror now moved this way. This is 1 meters, right? So they are left with what? 3 meters. I hope that is clear. So the question is, the distance between him and his image is what? Okay, now this is the object and this is what? The mirror. So the distance from here to here is what? 3 meters, right? Then if the distance between the object, which is the man, and the plane mirror is 3 meters, that means the distance between him and his image is also 3 meters. Is that clear now? Because from the characteristics of image formed by a plane mirror, it is the same size as the object. Okay, now that means the distance between the man and his image is 3 meters. That is from here to here, right? Plus another what? 3 meters, so that of his image. This is the object, but that of image is still the same thing as the object. So that is 6 meters. Do we understand? So if we have this type of question, the correct option is option C. I hope that is clear. I hope this video was helpful. Please don't forget to subscribe to this channel and turn on the notification button to get notified each time I post videos. And lastly, do not forget to share so that other students that are preparing for this forthcoming exam can also watch it and learn from it. I'll see you next time in the next one. Bye for now.